If we have this relationship of order between these five numbers, which of the statements are true? How could we validate, whether the expressions in the choices are true or not? Um, well, we could start testing values. That could be a way. If you don't like this, very uh, insecure methods, you can use algebra. But how? The idea is this. Always assume that you have a true statement. Imagine that A, B, C, and D are all true. And start simplifying using the properties of inequalities. Let's say, for example, this one. A times B is less than A. Okay? I assume that this is true for the time being only. And I will try to reduce this expression as much as possible, to simplify it as much as possible, to see what I get to in the end. At the same time, I will assume that the conditions the problem sets are also true. I know that A is supposed to be a negative number. So I will simplify A in this inequality. I will divide by A, which is the same as canceling A, right? But A is negative. So what has to happen according to the properties? The inequality symbol has to change, because we are dividing both sides by a negative number, which is A. A is less than 0 here. So what do I get? B is greater than 1. If you divide by A, you get B on the left side. If you divide by A, you get 1 on the right side. But then think about this. Is this coherent with the initial conditions? It's a contradiction. So this means this is false, because I'm supposed to assume that this is true. If I get a false conclusion from the assumption that this was originally true, I was assuming that this was true, then it is because my original assumption was wrong. So I can say, if the simplification of A times B less than A takes me to a false result, I can assume that the original expression was false. Okay? Do the same with all the other three. For example, if I want to simplify the second, what could it change? If I have A less than minus C is less than A minus B, what could I simplify there?
A.
A, right?
A.
I can take A and I would have negative C is less than negative B. Remember that in such cases, the inequality symbol doesn't change. But if I want to verify the true relationship between B and C, what could I do? Well, I could say I will take this to the left side, I will take this to the right side, and it would become B less than C. Or perhaps I could say, no, I will multiply both sides by negative 1, C and B, but then this would have to change, reverse. So in both cases, I obtain the same relationship. B is less than C. Is this coherent with the initial conditions set by the problem? Yes, it is, right? B is less than C. So I can mark this as a correct choice. Now, what about the next? 1 over B is greater than 1 over C. I know that there is a property that allows me to reverse or take the reciprocals of both sides of an inequality. Can I apply that property? What I would need to make sure is that these two parts of the inequality have the same sign. They are both positive or both negative. Now, can we tell? Notice the initial conditions here. What sign do B and C have?
Positive.
They are both positive. So if I divide 1 by a positive number, what do I get? Positive or negative? 1 is positive. Positive divided by positive, positive. Positive divided by positive, positive. So since the two expressions are positive, I can reverse using the property of the reciprocals. This is the same as B, and this is the same as C, and here I reverse this. So B less than C. Is this coherent with the conditions, the initial conditions of the problem? Yes, it is. B is less than C. So I mark this as correct. What about the last one? B squared is greater than A squared. Can we conclude something about this? So notice something interesting. Here we have something. B is a number, is a decimal between 0 and 1, a positive decimal. And C is a number greater than 1. Do you think, but here is not B and C, sorry, it's B versus A. So here the thing is, B is greater than 0, A is less than 0. So the square of a positive is always greater than the square of a negative. Just some examples. Here you have a positive decimal, B. So for example, I have 1/2 square greater than, let's say, A square. Let's say that A is 1/2 also, but negative. Negative 1/2 square. Because A is simply a number less than 0. What would happen here? If I take these squares, I see that this is false, right? Because they are equal. So I'm seeing that there is one case in which this inequality doesn't work. If B were 1/2 and A were negative 1/2, which are totally valid values for A and B, I obtain that this inequality is false because the two expressions are the same, are equal. So I can discard this as well. And my response is B and C.